Oh, good. All right. There was a funny error yesterday where it wasn't recording, and I'm not sure why, but it looks like we're okay right now. Oh, that was no good. So what we're looking at, we're in the chapter 11, which we're talking about interest rates and investments, loans, these kinds of things. And what we're going to get into today is what's called simple interest. So the idea of simple interest, it's typically an annual interest, though not always. And we have a particular formula for it. Now, first off, I want to talk about what interest is. So interest, you can kind of think of it and here, let me give you a more proper definition. I have kind of a personal one. And let's see, they don't really give a good definition here. So I'm going to give you kind of the descriptive, illustrative, I don't want to call it definition. But you can think of it as rent for money. Or rent on money. So this is how I like to describe interest. And the way you can kind of think of it, when you, say, rent an apartment or a house from someone, or say you're renting a room in a house. Well, if you're renting that room, well, no one else can live there. So what you do is you pay rent. And the idea with the person, someone loses an opportunity to live in that, say, room in that house. So I guess a way of thinking of it is if someone rents your house, they can't live in that house, but they get compensated for that because you're paying them rent. With money, you can think of it sort of like this. If you borrow money from someone, say you borrow $1,000, well, that's $1,000 they don't get to spend at the moment. So you're going to pay a kind of rent on that $1,000, and we call that interest. Now we have a formula for determining interest, and this is what we call the simple interest formula. So this is what it looks like. I'll describe what the parts are. But it's P R T. So I, of course, is going to be interest. P is principal. So principal, this is going to be the amount that you borrow or you lend to somebody else, or maybe amount of money you invest. We're going to see this a lot. R is the interest rate. And T is time. So just a little more on principal is the amount borrowed or invested. So principal could be amount borrowed or invested. Now, interest rate it determines the amount of interest paid in a time period. A common interest rate we're going to see is annual. And most interest rates we're going to be dealing with in this chapter are annual. But there'll be some that aren't, some that say like monthly. So usually the interest rates are annual, or it's a time period of 1 year. And the interest, it's going to be usually paid at the end of this time period. So usually at the end of each year, we're going to be charging interest. So for T, time is usually years. Not always, but usually. So for example, or not for example, but let's say again, if R, or the interest rate, is annual, then T equals years. Now say if R is monthly, then T equals months. Questions about that? So we're going to do some examples that illustrate this. Calculator. And let's see, take a look at some of the homework problems. So let's say we have this. And looking how they do this in the text, they basically just give you P, R, and T. So this is the principal. So again, this could be like how much you're borrowing. Say it's 12,000. Let's say the interest rate is 7.8%. And I forgot to mention that when we talk about the interest rate, we're going to talk about it as a percent. But when we actually include it in our calculation, we're going to convert it to a decimal. And let's say time is, take a look, 7 years. So the interest is PRT. P in this case is 12,000. Now for R, it's 7.8%. We're going to convert that to a decimal form, or a decimal, but non-percent. And then time is going to be 7. So often, again, we're going to assume this interest rate's annual. So that means the time period is years. So time t is going to be years. We multiply this together. We get $6,552. Now again, this is just the interest. So using simple interest, let's say you borrow $12,000 at an interest rate of 7.8%, which is kind of high, I think. I think student loans, they typically get about as high as 4 to 5%. And let's say you borrow this for 7 years. So at the end of 7 years, if we're computing the interest using simple interest, the interest alone is $6,552. So not only do you have to pay back the $12,000, but you also have to pay that interest as well. Right. So questions about that? So let me do another one. If I'm erasing too fast, let me know. So let's say we have this. So let's say you invest $500 at 2% annual interest, but you invested for only 6 months. So what would be the simple interest? So again, we're going to use I equals PRT. Now with T here, because this is an annual interest, we're going to have T in years. So we want to convert T, or to convert this 6 months into years. So 6 months times 1 year, which is 12 months. And we look at our conversion. The months are going to cancel. We're just going to be left with years. You have an invisible 1 under here. We multiply across, we'll get 6/12 years, which reduces to half a year. So that's going to be our time T, because T is going to be in years, and that's because the interest rate is annual. That means we have to convert this time period to years if it's not already in years. So this means we're going to use the decimal form of our percent. And multiply together, we just get $5. But the key thing to keep in mind is that we want to make sure our time t is referring to the same types of time periods as our interest rate is. So if interest rate's annual, t needs to be annual. If this was monthly, then t could be monthly. Questions about that? So let's try a different one. So we're going to borrow $1,000 for 100 days. It's 8% annual interest. Let's find the simple interest. So again, we've got a problem where we have annual interest, so we need time periods of a year, but we have days. So we're going to convert 100 days to a year. Now, there's going to be a catch here. So what we're going to do is convert 100 days. I'll explain what the catch is to years. It's going to be just a fraction of a year. Now, the catch is going to be this. I mentioned this in chapter 10, section 10.5. We have two different ways of, when we do these formulas, we can consider a year having two amounts of days. There's the exact method, or 1 year equals 365 days. Then there's something called the ordinary method. Where 1 year is 360 days. So we want to be careful here when we're dealing with days and we need to convert days to years. We want to be careful, are we dealing with an exact method or an ordinary method? And we typically use in this chapter the ordinary method, which is different from what we did in 10.5, where we used an exact method. So any questions about that? Well, what this means, to convert our 100 days, use this. 1 year equals 360 days. So days in top, days in bottom cancel. We're all right. We multiply across. We get 100 over 360. Or you could reduce that down. Say 10 over 36. Divide top and bottom by 10. And we could reduce this a little more. Divide top and bottom by 2. But really, you don't have to reduce it. That's all right. You can just leave it this way. That will be perfectly fine. Or like this, rather. But if you want to reduce, you can. So now we have our t. This is going to be our time t. 100 days is 5/18ths of a year, or 100 days out of 360 days in a year. So now the interest. Again, converting that percent to the decimal form. And so this comes out rounding to the hundreds place. $22.22. So questions about that? All right. So that's the idea of computing simple interest. Now, the next thing is what's called future value. Or maturity. And they refer to the same thing. It's just what you're calculating determines which term we use. So for maturity value, this is usually used when we're talking about loans. Future value, investments, or savings. So what this basically is this. It's the principal plus the interest. And we kind of ran into this a little bit in that first problem we did, where we had $12,000 and we ended up paying, after 7 years, $6,500 some extra dollars in interest. So we have to pay back the interest, and we also have to pay back the principal as well. So the way we represent this, whether it's future value or maturity value, we call it A. It's the principal B plus the interest I. Now, we actually have an expression for interest. It's P RT. And we've got a P in two places here. So we can factor out this P. Now, what's going to help factor it out? Let A equal P times 1 plus P RT. Factor out the P. And so this is another version of our formula. What we typically do, we might use this version, or we might use this version. So any questions about that? For the homework, you won't need to know how to get from here to here. It's just that this and this represent the same thing. So if somebody gave you, say, $300 interest and $1,000 as principal interest, you add those up to get your future value or your maturity value. But if you still have to calculate the interest, you could use this formula. So at the time that you have the money, or you're borrowing the money, or you're investing it, the interest rate, excuse me, and then the principal that's being borrowed or invested. So any questions about that? So let's see. So let's say you borrow $10,000 in student loans at 4% annual interest for 5 years. So we want to find a maturity value. We're talking maturity value because we're talking about loans. So again, we could use this. They didn't outright give us the interest, so we have to calculate it ourselves, and this formula takes care of both the principal and the interest for us. So principal, 10,000. Interest rate R, 4% or 0.04. And time's going to be 5 years. It's going to be years because it's an annual interest. So it's going to be, let's see. So 10,000 times 1.2, $12,000. So any questions about that? All right. So what this says is this. You're going to borrow $10,000 for 5 years at 4% interest, which is roughly what a student loan interest rate can be. It's like, for you, often they're 3.7 is very common. This is maybe be a little bit high. After 5 years, if we're using simple interest, you're going to need to pay back principal plus interest, total of $12,000. So this is the principal plus the interest. You have to pay back 12 grand. So that means the interest you picked up on was $2,000. Now, the next section, we're going to look at compound interest. And with compound interest, what we're going to find out is that we're going to pay interest on the interest. And it could cause some of this to increase over time a little faster. Well, that's in just a little bit. So any questions about that? Right. Well, let's do a future value. So suppose you invest $2,000, an annual return of 7%. So maybe this is something with the stock market, you're doing something like that. And you want to find the future value if this is able to maintain itself for 10 years. Well, take a look. Now again, what these future values / maturity formula is giving, it's giving the interest plus the principal combined already. So what we're going to find out is basically how much interest we're going to earn, in addition to we're getting our $2,000 back as well. So this will be what we're going to get is the $2,000 plus the interest. So if we were to go back to this account or this investment and pull all the money out, including what we invested, this is what we're going to have. So again, we're going to go with this formula. So the principal is $2,000. The interest rate, 7% or 0.07. And finally, time is going to be 10 years. And it's years because this is an annual return. It's kind of like an interest rate. It's like an annual interest rate. So we'll get 2,000 plus 0.7. And one thing you're going to see me do, I'm going through this step by step. It's easy to miss a number, especially if you're doing this on a test. It's easy to get rushed and you might miss a step. So I do recommend sort of slowing things down to help make sure you don't make any mistakes. And so this will be $3,400. So basically, you put in $2,000, come back to this account, and after 10 years, you have $3,400. Questions about that? All right. So that's simple interest. And then we have this application for simple interest, whether it's future value / maturity value. Now we're going to look at compound interest. Let's see. So compound interest. Well, the way this works is we're going to charge interest on the interest as well as the principal. So unless you're paying the interest off regularly, it's going to be put back onto the debt. So let's say you're borrowing money, and so you borrow some money, and then at the end of the year, you've picked up some interest that you owe on that loan. But you're going to keep this loan a few more years. So the next year when you pay interest, you're going to pay interest that's charged against what you borrowed, but also the interest you didn't pay. So what we end up doing is we charge interest on the principal and unpaid interest. So we charge interest on the principal and unpaid interest. So that means your debt is slowly growing and you're paying interest on this bigger and bigger and bigger amount of debt. So to kind of illustrate how this works, and this isn't going to be necessary for the homework, but I just want to go through it. Let's say we have our maturity value, and it's going to be principal plus PR, and we're going to let T be 1. It's at the end of 1 year, or just a period of 1 year, just a period of 1 year. So this is at the end of the first year, year 1. So at the end of year 1, we have principal plus the interest. And the time period is 1 year, year 1. So we'll get A is P plus PR. It's 1 times anything, doesn't change anything. And so at the end of the first year, the maturity value, how much we owe in interest and what we borrowed, factor out that P again, it's this. So at the end of 1 year, this is what we got. So let's say we're going to hang on to this loan more than a year. Let's take a look at, say, 3 years. So this is at the end of the first year. How much do we owe? Well, we borrowed principal P. And then at the end of the first year, we're going to have the principal plus the interest, and this is what it turns out to be. Now, let's take a look at year 2. Now, year 2, this time the principal is not going to be P, but it's going to be the maturity value from last year. And then we're going to compute interest. So the principal from last year, or I'm sorry, the maturity value from last year times R. And again, I'm going to do times 1 because we're only looking at this period of a year from the end of year 1 to the end of year 2. So we're doing this step by step. So we're computing this interest only for that 1 year period. So if we do that, I'm going to do one thing. I'm going to keep score, so to speak. So at the end of year 1, our maturity value is P, 1 plus R. So we're looking at year 2 now. Factor out a P. And again, this isn't for your homework. This is just to kind of motivate one of the formulas we're going to use. And if you did some factoring here, we get P is 1 plus R squared. So at the end of year 2, we're going to have A equals P times 1 plus R squared. So again, this is what we get for maturity value when we're computing the interest on the principal and last year's unpaid interest. So now we're to this. Let's take a look at year 3. So by the time we get to year 3, we're still paying money or paying interest on our principal and 2 years worth of unpaid interest. So what is that formula going to look like? Well, we take our maturity value from last year. That's going to be our principal. We take that same maturity value as principal again, times R. And again, we're going to calculate the interest from the end of year 2 to the end of year 3. So that means that's only a period of 1 year again. So T is going to be 1. And if we simplify this down, factor out B. And this isn't one that we've talked about in factoring, but you can actually simplify this down to this. All right. So what we're going to do, and this is going to come up when we go to chapter 1, which is interestingly enough out of order, but we will go to chapter 1. There's sort of a pattern here. You can kind of see a formula beginning to take shape. So at the end of 1 year, we're charging interest on the principal. So it's P to the 1 plus R. We could place in here, if we wanted to, an exponent of 1. Putting in an exponent of 1 doesn't change anything. 3 to the 1 or 3 to the power of 1 is just 3, for example. So at the end of 1 year, we're just charging on the principal. We get this formula. That includes principal with interest. At the end of the 2nd year, now we're charging interest on the principal and last year's unpaid interest. And so we get this formula. And notice that we have a 2 here. And at the end of the 3rd year, now we're paying interest on the principal and 2 years worth of interest that hasn't been paid back. And so we're going to use this formula, and now we've got a 3. So there's sort of a general pattern here. A equals P, 1 plus R, and we have T. So this is if we're paying it annually. Now, if you're looking in the text, this isn't actually the formula we're going to generally use because we don't always pay interest annually. Sometimes we pay it throughout the year. But any questions about this so far? All right. So here's the next thing. So interest is often charged throughout the year. So this is if we're charging at the end of the year. What if we're charging throughout the year? Now this is where compound interest can you get some very interesting results. Well, for example, let me talk about student loans. Student loans, you actually pay interest daily. At least that's last I checked. You were charged daily. Now, how do they charge this interest daily? Well, let me show you. So let's say we have this. So for example, suppose interest is charged monthly. And I'm going to just say this is an amount we'll represent with the letter N. So we'll say N is equal to 12. And this is the monthly each year, I should say. I'll leave that part off. So it's monthly each year. So what that means is 1 year, we're going to charge the interest 12 times. So what we do is each month we charge R over N for interest. So if R is 6%, let's see here. Yeah, 6%. Then each month, give you a second to catch up. So that means each month we're going to charge now come out to 0.005 or 0.5%. So when we deal with the compound interest, we're going to deal with this kind of thing, where we're going to be taking the annual interest, say of 6%, and we're going to charge a piece of it each month. And so we're going to charge 0.5% each month on whatever's in our account. It's going to be principal and then also unpaid interest as well. So what this does, this changes our formula. So this is R, and this is going to be years, but I can also think of it like this. This is the number of times we charge the interest. We did it 1, 2, 3 times because of 3 years. So what this will become is now our interest rate, if we're charging throughout the year, it'll be this R over N. And then in total, we charge, say, 3 years. So the total we charge here is the number of years times the number of times each year. So another way we can think about this is that T was actually the number of times we charged interest, and so in total. And so the total number of times we charge interest here is the number of times each year times the number of years. So if we're thinking months, we're doing this monthly, this would be 12, this would be 12, and this would be the number of years. That'll give us the total number of times we've charged this interest over the life of the loan. Questions about that? Again, you don't need to know this for your homework, but just to kind of bring in a little context of what's going on. All right. So let's do some examples. Now we're in section 11.2. So let's say we have this. P is 7,500. R is 6%. And let's say it's compounded monthly. And finally, T is 5 years. Now, again, for these problems, we're going to assume, unless it mentions otherwise, we're going to assume an annual interest rate. So that means annual years, and that's what we're going to keep in mind with T. So when we see compounded, that means we're using this new formula. So this means A is P 1 plus R over N NT. And plugging in our numbers, again, do the percent as the decimal form. So R, N is 12, then we have 12 times 5. The total number of times we're going to charge this interest. And again, this is going to give us the amount if this includes interest charged to the principal plus unpaid interest over the years. So we want to be careful here. You want to really sort of go step by step. You can do like this and this at the same time. That's fine. So 12 times 5 is it's going to be 60. Then what's 0.06 divided by 12? I think we just saw that. 0.005. The key thing's going to be this. We want to get a number here and then a number here. Once we've got this, then we're going to compute the exponent. And when we compute this exponent, we want to use as many decimals as we can. We don't want to round as we go. Now, there is a type of problem we're going to see later in this chapter where we will round in the middle of the problem. But for most of these types of problems, we're going to save rounding to the very end. And finally, we multiply by 7,500. We get 10,116. And rounding to the nearest hundred, since we're dealing with money, 38 cents. Questions about that? So if there's different compounding periods, so first off is annually. And that's going to be n equals 1. Semi-annually. That's n equals 2. Quarterly, n equals 4. Monthly, n equals 12. And then finally, daily. And we have to be careful with daily again. If we're talking exact, n is 365. But if we're talking ordinary method, n is 360. And we typically go with the ordinary method. Questions about that? So the next thing to talk about, there's some applications to this. There's 3, and it's present value, inflation, and the effective interest rate. And the idea of present value is we're asking this question is, if we want so much money in our account at the end of so many years, well, how much should we invest to begin with? So how much needs to be invested have a specific future value. So the way we answer this question we're going to solve for P, and we divide both sides by 1 plus r over n to the nt. We divide both sides by this expression. And so what that gives us, it'll cancel out here. Then on this other side, you're just going to be left with this. And so that's how we're going to compute present value. What it is how much money we need to invest to get an amount A, given that we have an interest rate R, we're doing this for so many years, and it's compounded so often. Any questions about that before I do an example? All right. Let me see. I want to say they actually give this another term. No, it's going with present value. All right. Here we go. So let's say after, say, 20 years, you want $30,000 in an account earning 8% interest. And in this case, we're going to be assuming annual interest. Compounded quarterly. How much? Should you invest? So the idea is that we want to get $30,000 in this account after 20 years. It's earning 8% interest, and we're going to compound it quarterly. So how much do we need to start out with? That's what we're trying to figure out. So A in this case is known. It's going to be 30,000. That's how much we want to end with. R is at 8%. 0.08. T is 20. And because it's quarterly, N is equal to 4. So now we're going to use that formula. P is A over 1 plus R over N, the NT. Or in this case, 30,000. 1 plus 0.08 over 4 to the 4 times 20. And again, we want to be careful with our steps. We're going to turn this into a number. We're going to turn this into a number, and then we'll compute the expo, or the exponential expression. So 80 And so now we can compute this exponential expression. We have 1.02 raised to the 80th power. Anyway, we're going to hang on to as many decimals as we can. So 875, 439, 156. So finally, we divide. And look at this, we get 6,153.29 cents, rounding to the hundreds. So what is this telling us? What this is telling us, if we want to, at the end of 20 years, if we want $30,000 to appear in our investment account, and that account is, let's say, earning 8% per year, and this is compounded 4 times a year, how much money do we need to initially plant into this account? Well, the seed money is going to be just over $6,000, $6,153.29. Let this sit in that account for 20 years, come back to it, we'll have $30,000. So questions about that? All right. So that's present value. The next application is inflation. And when we use the compound interest formula to compute inflation, we make a sort of an assumption. So for inflation, it's increases and costs that's right, of costs in goods and services. So increases of costs in goods and services. basically, it's the way I kind of think of it is if you were to buy something, you'll sometimes see this in newspaper articles where they'll talk about the price of something like in 1990, like a house might cost $100,000 in 1990, and then they'll give you a new price in so-called today's dollars, and that's taking into account inflation. So you might have seen that in some news articles. The let me think about this. Like a hamburger might cost 99 cents in 1990, and today it might cost $4. And that's what inflation. That's what you're seeing. And there's other things going on here too, but this sort of generalizing example. The thing we're going to try to do is calculate inflation, and to do that, we're going to use this. We're going to use our compound interest formula. We assume constant annual inflation. So inflation rates could be changing over time quite a bit, but we're going to assume that it's constant across the years. And we're going to look at it as an annual rate, like an annual interest rate. And then we're going to use annual compounding. Or in other words, our M is going to equal 1. So let's say we have this. So let's say the average monthly rent, and what they have here in the textbook problem is a 3-bedroom apartment in Denver, Colorado. So let's say that average is $1,249. So let's say an inflation rate of 7%. Let's find the average rent. Let's find the average rent 15 years from now. So we've got an average rent, say today, of $1,249, and the inflation rate is 7%. Let's find the average rent that's 15 years in the future. Now again, for inflation, our N is going to be 1. Now the principal is going to be this average rent. Our R will be the 7%, or the 0.07. And then the T is going to be 15 years. Again, we're assuming that this is an annual rate. So plugging everything in, 1249, 1 plus And n is 1. And this is what we're going to get in our formula. So again, using as many decimals as we can. And rounding to the hundreds place, we're going to get that. So what is this saying? Well, if an apartment has a rent of $1,249 today, this big 3-bedroom apartment, well then it's going to rent for $3,446.03 15 years from now. Questions about that? There's one more application to go over. It's called annual yield. You can call it annual yield. They also refer to it as effective interest. And it works like this. So what's been happening so far is we've seen basically 2 types of problems: simple interest problems and compound interest problems. And there's little applications to compound interest problems like inflation or present value. What we might be interested in, and this can help sort of untangle things, is when we see an interest rate, there's the rate, but then there's the compounding. That might make it kind of hard to see if something's a good deal or not. So what we can do is we can sort of translate the compound interest rate into an equivalent simple interest rate. So when we're talking about effective interest, we're taking a compound interest and we're looking for the equivalent simple interest rate. We're taking the equivalent simple interest rate. So that being the case, how do we do that? Well, first, we compute we have all our pieces in here. Let's see. Let me check one thing. I think my time. Yeah. So we're going to compute our compound interest formula. In other words, we're going to be given an interest rate. We're going to be given a compounding period. But we're going to do something about the time in the principal. We're going to let P be 100 and T equal to 1. So we're going to compute A like that. Then find A, the interest is A minus P. Now, what this is actually doing, because we chose P to be 100 and T to be 1, we're going to come up with the amount of interest that's earned on $100 for 1 year. And what that's actually going to tell us, this amount of interest will be the simple interest rate equivalent, or the effective interest for this compounded interest rate. Or the effective interest. So it's kind of an involved process. So we're going to go through an example, but we're going to compute a compound interest, but we're going to compute it with P is 100, T is 1. And then we'll have our given N, we'll have our given R. Then we're going to find the actual interest that was earned. And the way we find that is we take the principal and subtract it from the maturity value or the future value. That gives us the interest. And then I don't mean me, I mean this I, will be the simple interest rate or the effective interest. And the reason we can say that, the choice of P being 100 and T being 1 is helping us out here. That's this choice of numbers allows that to happen. So let's do an example. Let's see. So let's say we've got this. One bank offers (6.6%) compounded. Let's see, quarterly. A second bank offers 6.25 compounded monthly. Which investment offers a higher annual yield? Give me a second to write that down. And this will be the last example for today. Going a little bit over time. But what we basically have is this. You're going to invest some money and you want to invest money in an account. Well, you got 6.6% compounded quarterly, or a lower percent, but compounded monthly. So quarterly, again, we're compounding it 4 times, or N equals 4. Monthly, we're compounding it 12 times, or N equals 12. So we want to find out which one's actually going to have a higher return for our investment. So what we can do, for this one, again, P is going to be 100. T is going to be 1. R is 6.6% or 0.066. And N, quarterly, is 4. And again, P is 100, T is 1. This is what we do. This one, again, same thing. P is 100, T is 1. R, 0.0625. And M is going to be 12. So now we're going to compute A using this information and compute A for this information. Four times 1 is 4. On this side, squeeze this one in here. This might be hard to read. I'll read out the digits. And then 12 times 1 is 12. So what this one is, 0.005208333. Or I'll do it again. 0.00 or 0.0052083333. This is a 4. So you multiply by 100, and there's actually, we do have one more thing. We have to do one more step to find the interest rate. There is one more thing we do have to do. So there's one more step I forgot to mention, and it's going to be this. So these actually are not the interest rates. We have one more step to do. From both of these, we're going to subtract 100. Because 100, remember 100 is that principal. So when we subtract 100, we're left with the interest. And so we're going to get 6.76511543 on this side, 6.432118. I'll leave the 0 there. And this is actually going to be the interest rate. So approximately 6.76%, approximately 6.03%. So we have to subtract that 100. Don't forget that at the end. Otherwise, you're not going to get an interest rate of 106%. It's actually just going to be 6.76. So what does this tell us? Well, these are the effective rates, the effective interest rates. So what that means is that if we take these combination of interest rate and compounding, and we try to find, well, what would that give us? What simple interest rate would give us the same thing? Well, for this first bank, let's take a look here. They had 6.6% compounded quarterly. This is the same as a simple interest rate of 6.76%. The second bank, they were offering 6.25% compounded monthly, which is the same as a simple interest rate of 6.43%. So to figure out which account gives us the better yield, we compare these effective interest rates, or these simple interest rates, and this one is the better yield. And where did this come from? Well, it was the 6.6% quarterly. So that's going to be our answer. So that's it. Don't forget to subtract 100 here. But other than that, that's it for sections 11.1 and 11.2. A lot of complicated calculations, very easy to make a mistake. Does not hurt at all to go stepwise through everything, just in case you don't miss something. And this is one of those sections, and we're going to see more of them. They're going to get a little more harder, actually, in terms of computations. Going step by step is going to be really important. So just be careful. Good accounting skills, so to speak, or managing your calculations is going to be very helpful. So that's it. Any questions, let me know. Otherwise, have a wonderful day.
Awesome.